first letter of the acronym is the O. That stands for our origins investigation. We also, for origins, we're really going back to the dawn of our solar system. Before we had planets, before we had the sun, we were a giant cloud of rotating gas and dust. Inside that cloud, solid materials started to condense and grow into larger planetesimals, ultimately, in many cases, into the planets like the Earth, out in the outer solar system, the gas giants and the ice giants. Some areas of this early solar system had key organic materials and ices that accreted, and we think that was really critical for establishing the habitability of our planet, because we know by looking at the lunar cratering record that Earth went through a period of late heavy bombardment where thousands of asteroids were crashing into the surface. So to address the questions of how did the Earth recover from that event, we really need to look to sample return. And OSIRIS-REx is following on the footsteps of successful missions like the Stardust comet dust sample return, which you see some of the footage from rolling by here. And in fact, we're reflying the sample return capsule design from that great mission. And we need to get these materials into our laboratories because the kinds of questions that we're asking are really dealing with trace components in these solid materials. In some cases, we're literally talking about analyzing molecules that are present at the part per million level. And you just can't build an instrument on a spacecraft to make that kind of measurement. Not only that, but sample return really is the gift that keeps on giving. We're going to be able to address our science questions, but generations into the future are going to have access to this material. They're going to be asking their own questions. The next part of our mission acronym is the spectral interpretation. And we've been really fortunate with this mission in preparing to get out to the asteroid, to get access to some of the greatest telescopes on Earth and in space. And we're going to be able to ground truth that information with the science instruments that we're carrying right now. Here you can see the OVIR's visible and infrared spectrometer. This was built at the Goddard Space Flight Center. And this is going to give us information about the mineral composition on the asteroid surface. We are complementing that with the OSIRIS-REx thermal emission spectrometer built by our colleagues at Arizona State University. And combined, these two instruments cover a fantastic wavelength range from visible light way out into the mid-infrared. One of our key measurements is to look for signs of organic molecules on the surface of the asteroid to guide our sample site selection. The next part of our acronym we call a resource identification. And we're really thinking back to that sci-fi theme here and maybe one day getting out to these asteroids and using the resources to further space exploration. And we're going to greatly contribute to that vision because we are going to perfect the operational procedures for how you maneuver a spacecraft around a small microgravity body like Bennu. We're going to map the distribution of minerals and compounds on its surface, in our case to satisfy our science objectives of finding the right sample site.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Asgas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
COM.
Go.
Timer.
Go.
GC cube.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
AC is go.
Range coordinator.
Clear to proceed.
Launch director.
LD is go, and you have permission to launch.
Proceeding with the count. Timer T0 is planned for 23:05 Zulu. Set count to start at 23:01 Zulu.
Roger. T0 is set for 23:05 Zulu. Count will start at 23:01 Zulu.
Launch polling is complete, and we have a go for launch in 5 minutes, 37 seconds. Atlas liquid oxygen topping, followed by the call to transfer the Atlas
On my
and Centaur
mark,
stages.
T-minus 4 minutes and counting. 3, 2, 1, mark.
And we're at T-minus 4 minutes and counting.
3 minutes, 55 seconds.
Atlas and Centaur stages will be transferred from ground facility power to internal battery. At T-minus 1 minute 55 seconds, the team will command the ground launch sequencer to start, followed shortly by securing the Centaur liquid hydrogen and liquid oxygen topping activity. T-minus 3 minutes and counting. A brief look at the Mission Director Center in the Atlas Spacecraft Operations Center.
50 seconds.
FTS internal.
And the Launch Control Center. Flight termination system is on internal. Everything is going by the timeline. Standing by to transfer the Atlas power to internal and the Centaur power to internal in about 25 seconds. Once again, crowds gathered expectantly awaiting today's launch, a little more than 2 minutes away. T-minus 2 minutes and counting.
1 minute 59.
Vehicle internal.
155.
Launch sequencer start.
150.
Securing Centaur LH2.
Securing Centaur LO2.
140.
Launch enabled.
137.
Flight control system is to launch enable.
FTS armed.
In the final minute, the Atlas tanks will be verified at flight pressure, followed with verification of the Centaur tank pressures. 1 minute, 21 seconds and counting.
OCUs armed.
FCS count started.
115. 110.
Set out block.
T-minus 1 minute and counting.
Status.
Range green.
No issues with the range. Everything continues to be go. A final status check of Atlas, Centaur, and Osiris-Rex readiness will be conducted 25 seconds away from launch. T-minus 40 seconds.
Stable at step 3.
28. 25.
Status check.
Go Atlas.
Go Centaur.
Go Osiris-Rex.
Everyone is go. Standing by for launch. After liftoff, you'll hear the voice of United Launch Alliance's Marty Malinowski providing launch vehicle ascent data. 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of Osiris-Rex, its 7-year mission to boldly go to the asteroid Bennu and back.
Firing look good. Starting pump speeds and injector pressures are within family. Repeat chamber pressures have plateaued, begun to ramp off.
Heard the voice of Marty Malinowski. The Atlas has begun a pitch and yaw maneuver to steer to its planned path, 28.5 degrees inclination from the equator.
SRB chamber pressure is almost plateaued at this point. Already 180, injector pressures look good.
45 seconds into flight.
Whole program is complete. Boosters throttled down.
And the Atlas rocket carrying Osiris-Rex has gone supersonic. Standing by to pass through max Q, maximum aerodynamic pressure.
Max Q, vehicle body rates continue to look good.
This is the point when the mechanical stress on the rocket reaches its peak
And
because
booster
of the
has
rocket's
throttled back up.
velocity and resistance created by the Earth's atmosphere.
Signatures look good. Current altitude is 14 miles. Downrange distance is 9 miles. Current velocity 2,488 miles per hour. Range track shows vehicle progressing down the middle of the range.
In about 30 seconds,
continues to look
the
good. Pump
single
speed.
solid rocket booster will be jettisoned at 2 minutes 19 seconds.
And booster has throttled back down. It's now 50% of its liftoff weight. Next major event will be SRB jettison, coming up momentarily. we
And
have
you see the
indication.
solid rocket booster jettison.
Solid. Separation looks good. Vehicle has enabled closed loop Q alpha steering.
RD-180 engine continues powering the Atlas, Centaur, and Osiris Rex into space. Next major milestone will be booster engine cutoff. 4 minutes and 2 seconds into flight.
Valve has been fired. That system is now pressurizing to flight level. Signatures look good. Current altitude 40 miles. Downrange distance 75 miles. Current velocity 5,988 miles per hour. Range track looks good.
About 1 minute away from Atlas booster engine cutoff.
Already went to burn well. Pump speeds, injector pressures within band. Vehicle body rates look good. Vehicle is now 1/4 of its liftoff weight. Coming up on our and looking at the MECO 1 plus 3 second open shows Centaur's right where we expected, and comparing the pre-flight to the actual position of the vehicle.
We've orbited and rendezvoused with an asteroid, an S-class asteroid, with the Near-Shoemaker mission, exciting mission about 10 or 15 years ago. We've even sent something to collide with an asteroid to see what would happen. And these fantastic missions really set the stage for Osiris Rex to bring together the reconnaissance, the going, the touching, the doing the in situ, and then to bring it home. So that's why we're so unbelievably excited, because this is a dramatic extension of anything we've ever done with these priceless small bodies. You have the sample, you know, yes, we're there. And then, of course, then the long wait to get it home, but the wait's worth it.
Definitely. Well, thank you, Jim, for joining us tonight.
Watch this bird take off.
And as you can see behind me, our visitor center is filling up very fast. Can you tell me a little bit about the excitement in the room?
Oh yeah, well it's great that everyone's coming out at the dinner hour of the first week of school, and they're taking a break and coming out to watch this with us and to be part of the Osiris Rex mission. I'm really excited to see so many people here.
It's very, very exciting indeed. Osiris Rex will be launching very soon, and we are looking forward to seeing it lift off. So thank you, Lucy.
No, thank you. Let's go watch it and not miss the launch.
Okay, thank you both.